Hey guys, welcome back to my channel. In this video, I'm going to be continuing my series where I go over an entire IB chemistry topic in one video. And today I'm going to be continuing on from topic 1 and 2 and going into 3, periodicity. Topic 3, periodicity, is both an SL and a HL component, so this will be relevant to anyone who studies IB chemistry. And I'm going to be going through the understandings, applications, and skills and guidance, some of the aims as well, and a bit of utilization sometimes. And I'm going to be explaining each of the syllabus points as we go along. So without further ado, let's start off with topic 3.1, the periodic table. Firstly, we have that the periodic table is arranged into 4 blocks associated with 4 sublevels. So the SPD and F orbitals are this is the types of orbitals that we have from lower energy to higher energy. So it's from increasing energy. And from the periodic table, the S block elements, P block elements, D block elements, and F block elements show where the highest energy electrons are situated. Except some of the d orbital transition metals actually have s orbital electrons in their highest energy state, and that will be something we'll cover in a later video. But what the essential idea here is that the periodic table's position of atoms or elements is based on their sublevels that are occupied. The periodic table consists of groups. Groups are the vertical columns, and periods are the horizontal rows. That's just something you need to remember. The period number n is the outer energy level that is occupied by electrons. So if we had period 1, that means that the element's highest energy valence electron is going to be in the first energy level. If we're at period 3, that means the highest energy electron, or the valence electrons, or one of the valence electrons, is going to be in the third energy level. The number of the principal energy level and the number of valence electrons in an atom can be deduced from its position on the periodic table. So the period is used to deduce the highest energy electrons, or the valence electrons' highest energy level, whereas the vertical groups are used to determine the number of valence electrons. The periodic table shows the position of metals, nonmetals, and metalloids. Metals are to the left, nonmetals are to the right. Metalloids form that diagonal line between the two, and they have characteristics of both metals and nonmetals. Deduction of electron configuration of an atom from element's position on the periodic table. This should be covered already in topic 2, where you draw the full electron configurations for certain substances, certain elements. The term alkali metal, halogens, noble gases, lanthanoids, actinoids should be known. Alkali metals, group 1, halogens, group 17, noble gases, group 18, transition metals, that's essentially the D block there. Metals, which are the elements which have a partially filled D sublevel. Lanthanoids are the first period of the um, F block, which is just the separated block from the rest of the periodic table, and the actinoids are the lower one. The group numbering scheme from group 1 to 18 as recommended by the IUPAC. So we have to use the group numbering from 1 to 18 when we refer to answers, or refer to elements in our answers in IB chemistry. So if we're saying sodium, we refer to it as a group 1 alkali metal instead of a vertical column 1, or something more colloquial. So something interesting you may see already is that the periodic table is widely known because other disciplines, sorry, disciplines of biology and other sciences and other subjects, you make use of it as well. Uh, and periodic table is consistent of elements that are arranged also according to their properties. So chemical properties are based on the number of valence electrons, and as we said earlier, the number of valence electrons occupied on the outer energy level, as well, the valence electrons are the outer energy level. The number of electrons in the outer energy level, or the valence electron number, is going to determine how one element interacts with other elements. So that's going to determine its chemical properties. And so, since since the same group has the same number of valence electrons, elements in the same group are going to have similar chemical properties, and periods also determine certain physical and chemical properties. And you need to be able to analyze how they're organized. So you're going to talk about how the atomic number is used to order the order the atoms, but and elements. However, they're arranged and their positions are based on other properties. Be able to recognize physical samples or images of common elements. So if you see images of alkali metals, alkali earth metals, you should be able to know some of the properties you need to remember for alkali metals are they're shiny and they're generally easy to cut, and this will help you identify them in images. Topic 3.2 is periodic trends. So vertical and horizontal lines in periodic table exist for have trends for atomic radius, ionic radius, ionization energy, electron affinity, electronegativity. We've covered these concepts already. Atomic radius is half the distance between bonding nuclei, and ionic radius, ionic bonding nuclei, half the distance. Ionization energy, energy needed to remove 1 mole of gaseous electrons. Electron affinity is just like ionization energy, but adding electrons. Electronegativity, the ability to attract a shared pair of electrons in a covalent bond. So generally, these periodic properties will require another video, but you just got to think about, okay, if I'm going down a group, how is that going to affect the atomic radius? How is it going to affect these? If I'm going from the left to the right of a period, how is it going to affect these properties of the elements? Trends in metallic and non-metallic behavior are due to trends above. So when we talk about metallic and non-metallic characteristics, we're not going to just be talking about the position of the element in a periodic table. We have to consider their actual subatomic properties, so or atomic properties, which are these ones above. So the character of an element being metallic or non-metallic arises from these properties above. Oxides change from basic to amphoteric across a period. That just means more metallic substances with oxides form bases, and amphoteric means can act as both a base and an acid. So, like aluminium oxide is an amphoteric substance, and the nonmetals with an oxide are going to form an acidic substance. That's the general principle here. Prediction and explanation of the metallic and non-metallic behavior of an element based on its position in the periodic table. So you gotta consider if you're probably gonna be given an element and you gotta say is this a metal or non-metal, and then provide some of its characteristics. Discussion on similarities and differences in the properties of the same group. So alkali metals and halogens are the main ones you need to know. So halogens you're gonna talk about they act as diatomic gases generally. They exist like that. They exist as gases, solids. These are shiny. These are generally not. These can be poisonous. Poisonous may not be that much of a good answer to use. Construction of equations to explain pH changes for reactions in these oxides and oxides of nitrogen and sulfur with water. Okay, so remember how we said earlier how along a period you go from basic amphoteric to acidic when it comes to oxides. Well, sodium disodium oxide, I think that's just sodium oxide, magnesium oxide, and phosphorus oxide, or yeah, I'm not sure what that's called, and nitrogen oxides and sulfur oxides. We're going along period number three, period three. So we're going from basic, because these are metals, to amphoterics actually skipped here, but we're looking at non-metals afterwards, and these non-metals form acidic substances. So metals, oxides, basic, non-metal oxides, acidic. Because you can have this forming phosphoric acid, nitric acid, sulfuric acid, etc. Only examples of general trends across periods and down groups are required. So when you talk about the values or these trends along periods or down groups, you don't need specific values. You just need to know whether, say, electronegativity increases along a group and decreases down a group, etc. Group Group trends should include the treatment of the reactions of alkali metals, sorry, with water, alkali metals with halogens, and halogens with halide ions. So you're going to talk about how reactants and reactiveness of certain substances, such as mainly the alkali metals, changes along the group as well. So you got to think about like whether when and as you go along group one, so go down the alkali earth metals, do the metals become more reactive with halogens or become less reactive. Spoiler alert, they become more reactive down a group because alkali metals they react by giving up an electron, and as you go down a group your atomic radius increases, so the outer valence electrons feel less of a pull, less of an attraction with the nucleus, so it's easily more easily removed. So more easily it can bond with water, halogens. It can become metals. It can bond with halide ions, etc. And an interesting topic here, considering nitrogen and sulfur, is acid deposition. So this will be something we cover in topic 8 as well, so you don't have to worry about that much. I'll probably continue this video series to topic 8, and by that time we'll be able to cover this in more depth. Experiments with chemical trends directly in the laboratory through use of teach or demonstration. So by reacting certain substances that are fitting in the same period or group, you can observe how reactivity changes. Use of transition metals as catalysts. So transition metals, this is going to be in topic 13 mainly, but transition metals have variable oxidation states. So because of this, they can bond with multiple substances, and they have form a variety of bonds, and they can act as a base for which reactions can occur. Not base in the sense of acid base, but like a foundation or structure. And because of this, they are considered to be catalysts. Catalysts are substances which provide an alternate reaction pathway and reduce the activation energy of a chemical reaction. That's going to be covered later in topic 13 as well. Periodic trends can be studied with the use of computer databases that you don't really need to know much about. That's just the idea that online you can have like various resources that show these periodic trends. But other than that, guys, that's going to be all for topic 3. That's just 3.1 and 3.2. Next video will be on topic 4. This was a nice quick one, and if you guys enjoyed and learned something new from this video, please make sure to like and subscribe. It really helps out the channel. And comment down below any video recommendations you have for me so that I can cover them for you. And other than that, guys, see you in a new future video. Peace out.